Abby. Time to talk about functions. So here's some ways we tell if something is a function or not. From a graph, you do what's called the vertical line test, which means you try to draw a vertical line that touches the graph twice. If your graph passes the vertical line test, that means it never touches twice, yes, it's a function. If your graph fails the vertical line test, like so, this one fails because a vertical line touches twice, then no, not a function. They also sometimes draw these little charts, and it's like 1 points to red and 2 points to blue. As long as each thing in the first column only points to one thing in the second column, then yes, it's a function. But if one of these was to point to two different things, it becomes a no. This is no now. Because the 7 points to both green and red, and no thing in the first column can point to two different things, that makes it a no. So in this one, we have a list, and it's the same idea. Each x has to get the same y every time. So 1, 2, 3, 4, 5, 6. All three of those x's are different, so this is a function. Here's an example of one that is not. The same x, 2, gave us two different y's. So essentially 2 pointed to 4 and to 3, and it can't point to two different numbers. So this is not a function. All right, this one, again, different x's. 4 points to 8, 6 points to 8, 9 points to 8. Yes, it's a function. Yeah, I reused the 8's, but reusing the y part is allowed. We're really just checking the x's. And because each of these x's is a different number, yes, this is a function. Here we've got one, 2 points to 7, 2 points to 7 again. Okay, this is an example of a repeated x, but because it goes to 7 both times, then that's allowed, and this is a function. Because it's really just the same line twice, it isn't the same number pointing to two different things. So the only thing that disqualifies it is if the same x gives you two different y's. If all the x's are different, then you're fine. It's a function. If an x repeats, check the y's. As long as that repeated x has the same y each time, that's allowed. The whole point can repeat, but you can't repeat just the 2 and a different number at the back. Okay, then the last bit that's on here is about evaluating or giving a value. So they give you a function and they tell you what to plug in for x equals 1. Sometimes they write it that they want you to find f of 1. And that means the same thing. It means put 1 in place of the x. So here's what I did for this one. F of 1 would be 3 times 1 squared plus 1 minus 5. And then you just simplify everything. 1 squared is 1. And then 3 plus 1 is 4 minus 5 gives me the negative 1. The parentheses are important, especially when you get negatives. So for this one, I'm plugging in a negative 2. It's important that I wrote the parentheses. Notice I do it every time so that I won't mess up. But on this one, I put my negative 2 right there. So I get 3 times negative 2 squared plus negative 2 minus 5. So another way of saying this is that we're finding f of negative 2. That's just another way to say plug it in. 3 times 4, because negative 2 squared is 4. Negative 2 with the parentheses squared is 4. Negative 2 without the parentheses is different. It's negative 4. So we got to be sure we put the parentheses. Then plus negative 2 minus 5, and that's 12 minus 2 minus 5, which gives me the 5. All right, now let's put in something a little bit trickier. We put a negative x in. Again, they're going to write this as f of negative x. Oh, that's so sloppy. Sorry, friend. But I'm trying to see myself through the camera. Okay, so I put in the negative x. That's, again, the parentheses matter. 3 to the negative x squared plus negative x minus 5. So that means here I get negative x squared is negative x times negative x, which is positive x. So I get 3x squared minus x minus 5, and I'm finished. When we're not putting a number in, sometimes there isn't much simplification to do. All right, now I did f of x plus 1. So I put in an x plus 1. This one takes a little more work because, again, the parentheses matter. That means x plus 1 squared, which is x plus 1 times x plus 1, which is x squared plus 2x plus 1. And then these bits just stay the same. I distributed my 3 all the way through. 3 times the x squared, 3 times the 2, 3 times the 1. And then I put my like terms together. Okay, then they threw us a really tricky one. They asked for negative f of x. That means put a negative in front of the entire function. So I took that same function we've been using. I put a negative in front of the entire thing, which means it just distributes all the way through. This is different from plugging in a negative x. Do you see we got two different answers? The signs are a little bit different. When you plug in a negative x, you put negative x in for each x. A negative function means put the negative in front of the entire function. And last example I did, I found f of 2x. So I put 2x in every time there used to be an x. 2x, 2x, and then I get 2x squared is 2x times 2x, which is 4x squared. I multiplied that by the 3. And then this is as far as I can simplify because none of those are like terms. All right, that's all that's in this section.